Today we are going to learn how to solve a system of equations by graphing. A system of equations is when you have two equations in two variables. An example would be example 1, y equals negative 5/3 x plus 3, and y equals 1/3 x minus 3. Now, the only time that you're going to want to graph a system of equations is if both equations are solved for slope-intercept form, which means they're in the form y equals mx plus b. And if they are, all you have to do is pull out the slope and the y-intercept. So if we look at this first equation, the slope is a negative 5/3, which says I'm going to count down 5 to the right 3. And my y-intercept is a positive 3, which is the ordered pair 0, 3. For the second equation, the slope is a positive 1/3, which says I count up 1 to the right 3. And my y-intercept is a negative 3, which says is the ordered pair 0, negative 3. Now to graph these, I have to start by drawing my coordinate axis, which I can do on this graph paper over here. And you should have picked up one of these sheets of paper from the front table. I'm going to draw my axes, x and y. I'm going to label them x and y, and then I'm going to count off. It looks like I can count by ones on this, no problem. So I'm going to count by 1, 2, 3, 4, 5, 6, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, etc. I'm going to graph the first line in a different color to just make it easier to see. So this first line right here, I'm going to graph in green. My y-intercept is at 0, positive 3. So I'm going to go to the point, positive 3 on the y-axis, and put a point there. Then my slope tells me to count down 1, 2, 3, 4, 5 to the right, 1, 2, 3, and put a point. And I can do that one more time, down 1, 2, 3, 4, 5 to the right, 1, 2, 3. Just means I need to add one more point on my axis over here, negative 8. So I make sure it's contained in what I counted. I have 3 points, so I can draw my line. And I am going to extend it so it goes all the way to the end of the graph. Put arrows on either end. And then I'm going to write the equation on the line. In this case, my equation is y equals negative 5/3 x plus 3. And my first line is done. Then I'm going to graph the second line in a different color. I'm going to graph it in blue. My y-intercept is 0, negative 3. So this time I'm going to start down here at negative 3. My slope tells me to count up 1 to the right, 1, 2, 3. Up 1 to the right, 1, 2, 3. When I have 3 points, I can draw my line. And again, I make sure it extends to the end of my graph. And then I write the equation on that line, y equals 1/3 x minus 3. And the solution to the system is the point where they meet. And I can clearly see that these lines meet right here at this point. And that is the ordered pair 3, negative 2. So 3, negative 2 is the solution to the system. They meet at one point. They have one solution. Let's do one more example of that. Example 2. Example 2, they give me the system y equals 4x plus 3 and y equals negative x minus 2. For the first equation, my slope is a positive 4, which I can represent as a fraction by putting it over 1. And that says I'm going to go up 4 to the right 1. My y-intercept is again a positive 3 like it was up here. So that's the ordered pair 0, 3. Then for the second equation, my slope is a negative 1. which is like the fraction -1/1, which is I go down 1 to the right 1. My y-intercept is a -2. So that's the ordered pair 0, -2. I'm going to make a new coordinate axis over here. Uh-oh. It looks like I made it a little too close to the other line, but I think I can make it work. Again, I'm going to label it Y and X. I'm going to count off. I'm labeling by 2s, but I'm actually counting by 1s. Again, I'm going to graph in different colors. I'm going to do the first equation in green. This time it says I start at that +3. And my slope tells me to go up 1, 2, 3, 4 to the right 1 and put a point. Now I didn't leave myself a whole lot of room over here. So because I didn't leave myself a whole lot of room, I'm actually going to go backwards, which is the opposite, down 4 to the left 1. So I'm going to count from the original point, down 1, 2, 3, 4 to the left 1. I'm going to put a point there. When I have 3 points, I can draw my line. And again, making sure that it extends to the end of my graph. And then I'm going to write the equation on my line down here at the back. Y equals 4x plus 3. Then I'm going to graph the second equation. This time it starts at a -2. So -2 is right here on the y-axis. My slope tells me to count down 1 to the right 1. Down 1 to the right 1. I have 3 points, so I can draw my line. And again, make sure it extends all the way to the end of my graph. Oops, that went a little too low. That's what I did up there, I made it a little too long. Okay, I'm going to write the equation on this one. Y equals -x minus 2. And I can identify the point where they meet. I did draw my line a little off, and that is my fault. But if I were to count the opposite slope here, which is up 1 to the left 1, I could go up 1 to the left 1 and see that the line should have met right here at this point, and that is my fault. I graphed my line a little off. But they meet at this point right here, and that point is the ordered pair, -1, -1. And that's the solution to my system. That's where they meet. Now, when you're done with your notes on this paper, you should only have 2 graphs. I'm only giving you 2 examples. I want you to take your scissors, and beneath the second graph, cut the paper. And now your page should be a nice, neat size so that you can fit it in your notebook. So if you turn to the next page in your notebook, for me, that is going to be page number 30. I'm on page 30 in my notebook. In your notebook on page 30, you're going to take your notes. You're going to glue them in. Oops, I should probably move my page number up a little bit so you can read it. You're going to glue them in just like this so that you have them in your notebook, and you're going to put a title. And the easiest title for you to put is Solving Systems by Graphing. And make sure you put that in your table of contents as well. Solving Systems by Graphing. And it fits, if you only put 2 problems on here, it fits nice and neatly in the notebook.